welcome to another F5 Wednesday. Today we're going to be talking about essentially NGINX App Protect, which is our WAF functionality. Really, at the end of the day, it is some of our ASM functionality, a subset of our ASM functionality that's been converted over into NGINX and sits on top of NGINX. So if you're familiar with ASM, AWAF, Advanced WAF, you're going to be very familiar with some of these concepts. If you're not, some of the documentation around some of these same features are going to be very, very, very similar. So this is basically a subset of the functionality from ASM that sits on top of NGINX. And I'll get into what that functionality is and what's not there, and what is there and what you can configure and everything. Please feel free to ask any questions. Glad to answer anything at any time. If you would like to be unmuted, actually, we can, I can unmute you, and you're welcome to ask questions. So we'll go ahead and get started here. Just a quick, agenda, pretty much same agenda as we've had before. We're going to talk a little bit about previous topics, what problem NGINX App Protect addresses, and then how we solve that with NGINX App Protect. And then next topics, and we're going to go into a kind of a short demo showing some of the functionality, the attack signatures and data guard, how to install NGINX App Protect, etc. Previous topics, I won't hit on all of them. There's been quite a few. If you've missed some of the NGINX stuff, this has been recorded. We started 9:30 with a kind of intro to NGINX, what it is, how it can help my agency. Last week we did API management with NGINX, and then of course today we're doing the NGINX App Protect. So what kind of problem are we trying to solve here? So if you're not familiar with modernized apps and how those are kind of play into your organization, essentially we're with NGINX App Protect, we're trying to address how do I protect containerized modern apps, and anything that any kind of app that might fit into a containerized environment. That could be simply an API, it could be, kind of a regular, normal app that's been put into the containerized environment. So, a lot of these concepts that you would see in kind of a traditional NetOps environment where you've got a big IP sitting in front of apps apply here, but you can think of it as just sitting in the containerized environment. NGINX is much more lightweight than big IP, so therefore it can actually run inside the containerized environment. That's not to say that the big IP doesn't have a play for containerized environment. I'm going to kind of get into some of that. But if you want something that actually runs inside the containerized environment, you're really looking at NGINX. And if you're wanting WAF capabilities, you're really looking at App Protect. So it's some of the same problems that you run into in a traditional NetOps environment. You want to provide WAF functionality. You want to provide, capabilities to protect against OWASP top 10, CVE mitigation protection. But you're also looking at the ability to quickly spin up and spin down WAF instances. So that's really what NGINX is here to do. And you're going to see how quickly you can kind of spin up a WAF instance. I'm going to restart a couple during the demo, and you're talking seconds rather than maybe a minute, several minutes on the big IP, depending on what platform you're running on, VE or hardware. The other big thing is CI/CD integration and in integrating to a pipeline. So this kind of goes back to the ability to spin up WAFs dynamically and quickly, the ability to kind of auto-provision those WAFs, the ingress controller you can use NGINX for an ingress controller, and the WAF functionality can be layered on top of that. That has a declarative interface that I can dynamically provision the WAF policies and settings, so I can integrate that into my CI/CD pipeline. I'm going to show you a little bit about that. I'm not going to demo that today, but I'm going to show you some of the actual configuration and what that looks like, and I'll post some links in the chat if you're interested. The links will be at the end of the presentation, so if you guys want to copy the presentation, happy to send it out. So the solution here is, and the problem once again is, how do I provide WAF functionality to do CVS mitigation, OWASP top 10, basically web application security within a containerized environment? This provides strong app security. This is really designed for modern apps. What I mean by modern apps is, containerized apps, maybe that have been segmented out into APIs and smaller different microservices. and then is CI/CD friendly. What can we do? We can, it's fast layer 7 attack protection. Once again, OWASP top 10 protection. Another big one is regulatory compliance. WAF in general helps you, provides visibility into requests, what's going on in your application, so you can provide reporting and logging up to management. API security is a big one. I'm going to hit more on that, on exactly what features we offer there. IP blocking and the prevention of sensitive data loss, and that's really our data guard feature if you're familiar with the ASM module. So seamless integration NGINX, it's a module that sits on top of NGINX, much like, if you're familiar with NGINX and being able to add functionality to it. It's built on top of, you add modules into the NGINX process. The same thing here. That's essentially what App Protect is. High performance, many different deployment options. Big thing is it helps reduce tool sprawl, and it also helps you bring some of your NetOps functionality into a more DevOps environment. That's a big one. That's kind of along the lines of the minimizing tool sprawl. Very fast. We roughly about 20x faster than open source alternatives. We're really talking maybe about mod security there, and a very lightweight footprint. As far as being CI/CD friendly, we can automate security in the CI/CD pipeline. Obviously, this enables DevOps, application development, integration, which is a nice thing. And WAF, you really should be part of the software development lifecycle, and that really ties into the CI/CD pipeline integration. If you're really part of that, agile development, and you're doing a lot of different tests, and you're putting out new code very often, you really want to have dynamic configuration capabilities to be able to deploy WAF and its different variations, because as the application changes over time, so is your WAF policy. It has a very good chance of changing. At least you're not going to typically have a static WAF policy. You're going to want new features. The application is going to change. You're going to change what URLs you're looking at, what you're doing with them. You're going to maybe change attack signatures based on what type of applications, what's been done to the application, what new features it has. So those are all things that you need to think about. The other time is, how quickly can I get up or install and get up an application provided out to the public. And obviously this comes as a reduced cost. The more automation I have, the more things that are put into a CI/CD pipeline. The idea there is I have less operational costs. So that's where the reduced cost comes in. Let's talk a little bit about the deployment options. So if you're looking at this box to the right here with the API gateway and the ingress controller and monolithic apps, API endpoints, this is really your application environment. And then you may have API endpoints and then definitely Kubernetes pods inside of a containerized environment. And if you're coming in, as a client coming into this environment, you have the ability to put what we call, at the edge, put NGINX App Protect, or even NGINX itself at the edge as a software load balancer sitting outside of these environments. But then you also have the ability to move it inside to the environment and have it, be an ingress controller, or actually sit in front of the pods, or actually into each individual service. You can have it sit in front of API gateway. So you may, at the end of the day, have multiple instances of NGINX and App Protect, just depending on how your environment ends up looking at the end of the day, sitting inside of the containerized environment. I'm gonna get a little into that a little bit here. So one option is to have it kind of on the edge as an ingress controller. I can do policies on a per service basis or a per pod basis. And each of these different options I'm going to talk about each have a different cost and, kind of the pros and cons to them. I'm going to detail that a little later. But, you can have it live outside the environment. Pardon me, it looks like I skipped a slide here. You have it sitting at the edge. I can have it as an ingress controller. And then I can also have it per service proxy, in where that's, essentially I'm each time someone needs to talk to a service within a containerized environment, it's going to go through its own unique instance of NGINX App Protect. The other option to that, and more common option, is to have it on a per pod basis. Now, a pod is a grouping of containers, and typically that's going to represent one single application. So I think you probably, if you're following this, you probably understand the cost benefit to this, and the difference between having it in a per service proxy or a per prod proxy. Per service proxy, you're going to typically have an NGINX app instance per service, but the reality is each pod is definitely going to have is going to be a grouping of similar services. So you're going to typically have that NGINX instance service all those applications within that pod, and that's the more common use case. It's less operational overhead. You have less resource usage, but there is we just want to highlight that there is the option of having it per service if you want. And I apologize, I have a slide out of order here. I'm not sure how that happened, but here's kind of the summary of that. Having it at the edge where big IP can live outside of the environment, have it as an ingress controller. Big IP can also do that using our container ingress services plugin. And then you could have it actually, living inside the containerized environment, being per service proxy or per pod proxy. And probably at the end of the day, those are going to be the more common use cases. I would say, if I were to bet, most customers are going to typically install, have big IP sitting in front of them if they're doing ingress control or at the edge, sitting outside the environment. If they're inside, if you're wanting WAF functionality inside the environment, you're really most likely going to look at per service or per pod, and those are just the more more common use cases for NGINX App Protect. But the reality is you can do any of those with NGINX App Protect. Big IP WAF, right, can only sit at the edge and ingress controller, whereas App Protect can do all four of these. Skip ahead here. Let's get into some of the features. Like I said, if you're familiar with ASM, this is going to be very, very familiar to you. And a lot of the configuration is almost exactly the same for the features that exist in App Protect. So App Protect offers the ability to do file type restrictions. I put that under access control. I can do URL control. I can do IP blacklisting. I also have header protection. I can do header enforcement, length enforcement, meta characters. I can use attack signatures to scan headers. I can do cookies and method enforcement, which both of those are part of, they're technically headers. Most things that we're looking at actually is technically a header. Also protocol attacks. We can protect against protocol compliance, evasion techniques, API security, which is something that Doug touched on last week, and something that's kind of newer to ASM, but has also been ported over to App Protect, is the ability to import an open API or Swagger spec file, which gives you a definition of the API, what methods, what URIs, what parameters are used within that particular API, and then that builds you a very nice policy very, very quickly, depending on how filled out that spec file is. If it's very detailed, you're going to have a very detailed policy. If it's less detailed, you're going to have still a good policy that you could tweak and add on to, but it's still going to be a very, very good start. So you can get very coarse or fine-grained control there, and I'll dig into that a little bit later. Another piece of this is you also have the ability, if anyone's ever done anything with content profiles in ASM, you have the ability to do JSON and XML schema enforcement there. And you can enforce different links, and it verifies that it actually is correctly formatted JSON and XML. It doesn't have the full feature set that the ASM, the schema validation for XML, it does for JSON, but it's, all that's coming in future releases. But it's a good subset to that. The other part of it is, no WAF would be complete without this, is attack signatures. So there is signature-based protection. We offer something called F5 threat campaigns as well, which are kind of more specific signatures that are developed in-house by F5 Labs based on the current trends, going on the internet. These aren't anything that are like CVE specific, which attack signatures tend to be. These are more looking for behavior using signatures that's going on your website. And then of course, we also have the ability to do attack signatures, which, the typical use case for that is protect against SQL injection. I need to protect against the stretch CVE. That was one that came out a couple of years ago that was very big, that quite a few of our customers ran into. And cross-site scripting, like I said, SQL injection, XXE, stuff like that can all be detected with signatures. So the attack signatures are also developed in-house by F5. They're not third-party, and they're updated along with the ASM signature. So the signature capabilities that you get with ASM, you also get with App Protect. And then another piece of it that's not necessarily specific to App Protect is TLS and cipher enforcement. So that's really kind of an NGINX thing. But I put that on here because that is part of the OWASP top 10 mitigations, is having secure transport. And you can enforce ciphers, TLS versions, everything with NGINX, which obviously App Protect can do as well, since it runs on top of NGINX. And then you have the ability to look at response pages. So a WAF typically is looking at just inbound requests coming into the website. We're not typically, a WAF is typically not looking at the response data going out. There are exceptions to that, and one of those exceptions is something called Data Guard. Once again, this is another ASM feature where I can look at data, look for patterns like social security numbers, credit card, or any kind of pattern you would deem sensitive or that you don't want leaving your infrastructure, and you can put that on a per page basis. Just gonna, pardon me, get a little more into each feature. So the attack signatures, like I said, are written in-house by F5 security. This is not a third-party thing. It's written in-house. We get updates about every week or 2 weeks. More immediate updates come for bigger vulnerabilities that are out on the internet. They're web application specific. And this is really, if you're familiar with ASM, kind of our, part of our negative security model, where you're protecting against known web attacks. So these are known attacks that are out there that we're protecting you against. Similar to what an IDS or IPS would provide, but just web application specific, not, different than an IDS IPS in that an IDS and IPS would typically provide signature protection across many different protocols. We're really just talking about HTTP here, since web application firewall. Updated as new attack signatures are discovered. And it's really important with the attack signatures that you tighten down the attack signatures using server technologies, such as, you want, if you have attack signatures or you have an application that's maybe Linux, MySQL, and PHP, for instance, you want to make sure your attack signatures are only looking for MySQL, not Oracle, looking for Linux and not Windows, and PHP and not ASP. And so, when an attack or some data comes in, what happens under the hood is each attack signature, regardless, is applied to it. Even if one has been triggered and found, a violation has been found, it still goes through each attack signature. So if you can minimize the number of those, obviously you improve performance, and you also reduce false positives, because if you alert on ASP.NET attack signatures triggering, but you have a different application language running on the application server, you don't care, right? You don't care that something triggered for something that you're not vulnerable to. Protocol compliance. This is a kind of an easy one. If you're familiar with the HPRFC, there's certain things that are expected. For instance, you only have one host header. Get and head commands shouldn't have a payload in them. That would be a post command. If you have a post command, you actually have to have some data, and you have to have a content length. So we enforce, things like that. There's a list of about, I think there's about 20 things that we check for by default. Multiple content length headers is another one. So this is a pretty benign thing that that the web server should be doing on its own, but you'd be kind of surprised. And sometimes, administrators on web servers turn these things off, these checks off, when they shouldn't. So, even if you think you've already got it, right, you should enforce it here as well, just if for anything defense in depth. In case someone's misconfigured something or it's not doing what it's supposed to be doing. Another one that we offer is Evasion Techniques. I always use the kind of an easy one that a lot of people remember, and it kind of shows my age here a little bit, is the .. I'm trying to access a directory from a web request. So that was in NIMDA way back in the day. So we look for stuff like that. If someone puts in Unicode in the URL or something like that somewhere in the web request, we make sure that's done correctly, and they're not, we decode all that stuff correctly. Sometimes there's legitimate uses for some, depending on how the application's written, but that's pretty rare. So this one's a fairly benign one as well. And as I mentioned before, DataGuard, which is looking at the response data coming back, we kind of advise caution here. You don't turn this on for all your pages. You're going to be typically very selective in what page you want to turn this on. This does affect performance. Like I said, because by default, we're not looking at response data. So you're going to want to configure it for known URLs that may have data that you don't want leaking out. So you got to be, ideally that's the way it works. Not that you can't turn it on across the site, you can. You just gotta, if you do that, you gotta kind of, monitor performance, and it is going to be a performance hit. And then, as I mentioned before, header enforcement, we can enforce the lengths of headers. You can define headers as wildcard or explicit, so I can get very granular in how I want which headers should be allowed and which ones should be enforced, meaning they should be required in the request, and then which ones I should be seeing. I can do cookie enforcement, which is obviously a header. We do attack signature detection on in case someone, it's not uncommon to see, cross-site scripting attempts within header data. So you want attack signature scanning of that part of the request. You can also control methods that are allowed. A lot of people don't think of get, post, put, delete as headers, but they are technically headers. So you can go in and control and get very granular. And this is very, very, very appropriate for APIs. And I'll talk a little bit about that later. By default, get, post, and head are allowed in a default policy. You can obviously override that and get very granular, either across the site or per URL, which methods should be allowed. File type enforcement is another one. I can enforce an alert on all the different file extensions. I can say, .php is allowed, .text maybe isn't, even though maybe .text exists on the web server, but it shouldn't be accessed. So this is like if, someone's pushing out code that maybe has extra files in it that it shouldn't have, and they push out to the site, you can control that at the WAF. So you can get very, very granular here. They're case sensitive like everything else. Wildcards are supported. You can get very explicit with which file types, I can do like start, PHP or PH star or something like that, in cover if I've got like different versions of PHP file types on there. This is also a very simple way to achieve part of the OWASP Top 10 2017 number 5, which is unauthorized access. So if I can control what requests should actually come in and hit the web server, I can control, the level of access that they have. So this is a very, pretty easy way, and you don't necessarily have to get real granular. You can, file type enforcement, it goes a long ways. You don't necessarily have to define every last file on the web server. Another one is parameter enforcement. We can, once again, alert and enforce parameters. We can enforce the values of those parameters, whether alphanumeric, binary, Boolean, integer. Once again, you can do wildcard. They're case sensitive. I can enforce meta characters. A good example and use case of this would be password and username enforcement. So, for instance, if I know my usernames have a certain format, I can enforce that by looking at the username parameter and making the meta characters, and you do meta character enforcement there. Conversely, I can also do it on the password as well. I can actually set links, and I can set you know, what meta characters are allowed once again, so I can actually say, you know, you were required to see these you know, these characters, or these characters aren't allowed. So it's kind of an interesting use case of it. Another one, if you're familiar with ASM, is sensitive parameter support, where maybe you have a password parameter and you're logging that parameter, but you don't want, you know, you obviously don't want to have the actual password logged in your logs. So what we can do is you can mask it out. And you can, in the logs, it'll just be asterisks out, anything that's been deemed sensitive. So password would be a very, very common, or probably the most common sensitive parameter out there. And then I can get very granular per URL. I can do parameter enforcement per URL as well. Speaking about URL enforcement, I can get very granular what URLs should be allowed. Once again, they can either be explicit or wildcard. I can enforce meta characters on there. Kind of less common, but it's an option. I also can enable attack signatures per URL. I can do method enforcement per URL, which is big in API security. And then I can also enforce content per URL. And this is important because I may have a mixture of different contents within my application server. For instance, I may have XML, JSON, and HTML. And I can enforce that, right? I can say this URL should only ever see XML content. This URL should only ever see JSON. And this is, once again, you know, as you probably guess, very important for API security as well, because you're going to want to enforce the maybe JSON or XML, and that's really where we get into the, as I mentioned before, the, you know, kind of the schema enforcement portion that's done through content profiles. API security. This is a very cool use case in that I can get very, very granular in what you know, my API is essentially a mixture of URLs and parameters that come through, and I get very granular as to what methods, so I can hit what URL with what parameters. And why I say that, and kind of a cool use case of that, is the ability to make certain parts of the API or the entire API, or, like I said, you get very granular in this, read only, read write. So if I have a part of an API that I know should only ever get reads, so it only should ever have gets, I can enforce that. And then if I have another part of the API that I know has the ability to accept data, so I can do a write to it, I can enforce, you know, get and a post to that one. So you can get very, very granular there. And once again, you can, you know, enforce JSON, XML content. And then another big one is the ability to scan the content with our attack signature, so you can protect against CVEs and other malicious attacks. That is the end of the presentation. I'm going to talk a little bit about next topics. Next week, we're going to discuss how to manage NGINX instances with NGINX Controller. That's from 1 to 2 p.m. And then the following week, we're going to actually have a 2-hour session on NGINX Controller for Kubernetes. And that's going to start out with a short discussion, and it's going to be mostly lab time. So that's a 2-hour one. You only need your, you know, if you've registered, all you need is your some device that's got web access on a web browser. That's really all you need. You can do everything from there. And I think I've got someone in chat. All right, not a question, just a comment. Here's some resources. I'm going to quickly post these in the chat so you guys have access to them. If you want this presentation, once again, you know, feel free to ask us for. We'll be happy to send it over. You can ask your account team. We can get it to you through them. And then we're going to do a short demo here. So give me just a second. And let me. Let me get those links for you real quick. Post them in the chat so you have them. Some pretty good data there. Not 100% Zoom, it can accept all that, and it does, it looks like. So there's the links. If you guys are interested, you can look at them while I'm talking. No worries there. And let me share out the demo here. All right. So what I've got here is a couple different NGINX App Protect instances. And for the sake of, I'm sure you guys don't want to see it get installed, but that was part of the demo. I went ahead and installed this. You can see what commands I ran up here to install App Protect. There's quite a bit of stuff. So I went and ran yum install EPL release, and then I installed App Protect module. It's an RPM file, and you can see all the stuff that it went through to install that. It took a little bit of time, so I wanted to kind of cut that out. Then I copied some files over that automatically had App Protect configured, the logging policy. In this demo, we also set SE Linux to we turned it off. SE Linux is supported. You just have to go in and do some stuff with the depending on your what version of Linux you're running. You have to do some stuff and turn certain things off. So kind of an easy way to do that is just turn it off. So I did that for the demo, and obviously restarted NGINX to pick up the new configuration. This is how you restart it, and then that's got App Protect enabled, and then I will kind of go through. Let me just show you a little bit about the policy or the actual configuration file. Pretty simple configuration. So I've got App Protect turned on here. I've got my policy file turned on as well, and I'm logging. And I've got my logging definition here in this log default.json. Another kind of interesting thing that I'm doing is I'm logging to something called Kibana. So I've got an elk stack installed here, and that's essentially taking in all the violations that come out of this demo and putting into kind of a nice, easy, searchable, reportable format. And this is an open source tool. You can look at it, online, and you can download it for yourself. And so we've got that running, and I'll show you the results of that. So let me show you. One last thing. Let me show you the actual policy. So this is the configuration that enables App Protect, but then I also have the policy, and I can do a policy per URL or per application. So you may have multiple policies per NGINX instance, or you could have multiple instances, each with its own App Protect, which is kind of the way ASM is done today. You typically have a virtual server enabled with, and you have a single policy on it, although you can do multiple policies, but the most common use case is a single policy per virtual. And I would say that's probably going to be depending on, it really depends on how you have your environment set up, but you could have, if you have it more out front of everything, obviously you're going to have multiple, policies, and pick off the URIs and everything there and the services. Or then you can have it sitting in, just in front of a pod, which has a single application, right? And then you have one policy for that. So like I said, it depends on how you have your environment set up and configured, but either way, it's flexible. Let's show you the policy real quick. Notice that I'm pointing to this default policy _JSON. Very simple policy. If you're familiar with ASM, once again, we have the templates, and there, there's a base configuration. We've got this in blocking. And let me show you an attack real quick. I'm going to do a cross-site scripting attack here. Once again, you're familiar with ASM. You're probably familiar with this response page where I get it rejected, and then I have an ID so I can track it. If someone's, a client is saying, hey, I'm getting blocked by the WAF, you could have them send you the ID and you can look for it. And if I go to, pardon me, if I go over to Kibana here, I can see the attack and what it logs. So this is configurable by that log default file that I kind of showed you, I referenced to. I can put log certain fields, not log certain fields. I can make some of them sensitive. pardon me. And so I can, kind of make what this look like, what I want. This is more or less the kitchen sink and just about everything we log for the most part in here. So you can see, the reason, it'll have the method, it'll have the support ID, once again, that you can search on, the signatures that were triggered, timestamp, what policy it was, if I have multiple policies, URL, etc. So everything that you would see in ASM, a log request, you would see here as well. So now I got the blocking page. Let's just show you how to change it to transparent. So if I go in here, remember the enforcement mode I showed you is by default blocking. So if I go into, actually I can just pull this up here. Whoops. If I go in here real quick. Once again, if you're familiar with ASM, this is going to be really familiar. Even the names and everything are the same. So if I change this to transparent, make sure I spelled it correctly, and then I do a system control restart NGINX. Oops. Let me kick up a new instance here because I need to. Here, actually, I'm just going to do that. I've had these running for quite some time, before the demo starts. So I think I had a little authentication time out there. So I did that, good. And then if I do system control, restart NGINX, this will give you an idea of how quickly you can spin up an instance, because you're essentially spinning, bring up a new instance of NGINX. So, roughly, 10 seconds, something like that. So that's how quickly you can spin up an instance of NGINX. So now if I go back and I run that attack again, oops. Yeah, it got through, right? So it's NGINX, that's the NGINX error. It gives me a 400 error saying, that URL doesn't exist. So that's that. And if I then go into, I'm not going to show this, but I want to, this is going to be a common question, is if I wanted to update my attack signatures, this is what you would do. It's all done through RPM. So this is how, if you go into ASM, familiar with ASM, you go in and click update signatures. This is how you would go through and update your, get the latest and greatest signatures available. I won't do that right now, just in the interest of time. It takes a little bit of time to do that. And I can also, downgrade. So if I do a yum downgrade, I can downgrade and get an older version of the attack signatures. Right now, custom signatures aren't supported. It's something that's coming in a later release, but that's something that is supported in ASM today. And then, I can also update threat campaigns this way as well. Kind of in the same manner, you just go through and go through yum and update the threat campaigns package. So another thing I'm going to show real quickly is DataGuard. And let me go over to another instance that I've got configured over here. Let's just make sure that I'm logged in. Okay. So if I go over to, let me show you the configuration real quick. Here. So I'm actually pointing to a different policy here. I'm pointing to a CCN policy. I've got it commented out, so it's not enabled right now. What I'm going to go through is show you it not enabled, and then show being blocked after we enable it. And let me just show you the CCN policy. So that's for credit card number policy. This is what the policy looks like. Like I said, once again, if you're familiar with ASM, you're going to be very familiar with these kind of configuration items. You know, you can go put what URLs you want to enforce in there. You know, turn on credit card numbers. Do I want to mask the data? That means when it's returned out, the WAF returns that data. Does it asterisk out so it doesn't get leaked? You know, whether it wants to be enabled or not, and then how many digits as well. And so let me show you this not enabled. So it should get through, and then I'll show you enabling it and what it looks like there, kind of similar to what we saw earlier. Just a second, looks like copy and paste translation with single quotes. Oops. Oh, my apologies. I forgot to start NGINX here. Looks like I skipped over that. Sorry about that. Yeah, so it made it through. That's an NGINX error, HTML. Now if I go in to the policy or to the NGINX configuration, I can then enable that policy is what I'm going to do. Restart it. Yeah, once again, pretty quick, under 10 seconds. And now you can see it's being masked. So that's something that wasn't masked before. So this is, you know, DataGuard working, not allowing. Remember, DataGuard is looking at the response, and you're looking for patterns. We found a pattern. We masked it out, so it's not allowed to leak. So it's kind of a, you know, a DLP light functionality. Kind of cool there. And let's see what else. I've gone through some of the configuration. Is there anything else anybody want to see while I'm at it? That's all I had for the demo. If you got something, let me know while we're still on, and then I'm going to show you real quickly. You've seen Kibana, you've seen what the logs look like. This is one of the articles or the links I sent you. And this talks about the ingress controller configuration, which we're going to talk about and do a lab on in 2 weeks. In the, you know, kind of how you can push a declarative configuration over to the ingress controller for the ingress controller itself and for the App Protect portion. Here is what a kind of a bigger configuration would look like. So this is pretty interesting. It gives you, it's not everything. One of the other links I sent you has a full spec or the schema for the entire declarative interface. So you can take a look at that if you're interested. But here's a real world example of that, and actually a setting. Like I said, we're not going to go through a demo of this today. This does require Kubernetes because it goes on top of the ingress controller. But I want to at least show this to you, you know, a kind of example of what it looked like. And once again, if you're familiar, I know I keep harping on this, but if you're familiar with ASM, it's going to be this is going to look very, very familiar to you. And, you know, kind of the different settings, you know, for the protocol compliance and the different violations, what application language, what template you're using, number of parameters, the file types you can enforce, DataGuard once again, cookie enforcement, and then evasion techniques. So it's a pretty good you know, list of some of the features. Once again, if you go over here, you can actually go to the declarative spec and you can see all the different options. So this is a more complete view of it. So, well, that's all we had for today. Looking forward, for next week. And in the lab, if you know people that haven't registered, there's still time to register, still lab spots open. We're not really capping that. So if you have somebody interested in the lab, please have them register. And I appreciate everyone's attendance today. I hope this was informative, and we'll see everyone next week. Thank you.